COVID. So now let us see a comparative study of molecular arrangements in solid, liquid, gases based on kinetic molecular theory as provided in the following table. So the parameters. Packing of molecules. Solids are closely packed as I have shown you here. See, solids are closely packed. Let me try taking it downside. Now let us see. So in solids they are closely packed, in liquids they are loosely packed, and in gases they are very loosely packed. Intermolecular spaces, there is very low intermolecular spaces here you can see. In liquids it's more than in solids, and in gases it's the highest. You can see pink refers to the intermolecular space. Intermolecular force of attraction, as molecules are close they are having most intermolecular force of attraction. In liquids, it's moderate force of attraction, less than in solids. And in gases, they are not having any intermolecular force of attraction. We can't count it, therefore it's negligible. Molecular movement. It can vibrate only, it can't move as there is no space between them, very much less space is there. Therefore they can vibrate, but their mean position is fixed. In liquids, they possess translatory and rotatory motion in addition to vibratory motion in one motion. They are having space, therefore they possess these all motions. And in gases, they possess translatory, rotatory and vibratory motion in all directions. What do you mean by translatory motion? What do you mean by translatory motion? So it's the motion in which all points of a moving body move uniformly in a same line or direction. Suppose this is one molecule, it can move in the same line and direction and comes to here, this final position from this initial position. It's the translatory motion. Rotatory motion, this is the rotatory motion. From here to here. And vibratory motion, this is the particle, it vibrates and comes to this, and again it vibrates and comes to this position. This is the connection like this. Okay. So these are the types of motions which occur in liquid, gases and solids. So kinetic energy, very low kinetic energy in liquids, as they can only vibrate, they can't move. In liquids they are having high kinetic energy, and in gases they are having the highest kinetic energy. So now let us see the interconversion of states of matter. Since the physical behavior of matter in various states depend upon the molecular arrangement, which can be changed by changing the conditions of the temperature and pressure, as I had told you. Therefore, matter can be converted from one state to another under suitable conditions. This is also termed as the phase of transition. Now let us see interconversion between solids and liquids. How solids and liquids convert each other's states. So the process of conversion of solid state to liquid is called melting or fusion, and the opposite process from liquid to solid is called freezing. You might have seen that your mother have kept water in the molds in the freezer. After some time you might have observed that the water gets converted into ice cubes. Why? This process is called freezing. And you might have observed that your mother have kept the ice cubes outside the freezer, and after some time it gets converted to water. So this is called melting. Melting is carried out by supplying heat energy to the solid substances, and freezing is carried out by extracting heat energy from the liquid substances. What is melting? When the substance in the solid state is subjected to heating, that is some heat is provided, heat is absorbed, the molecules absorb heat energy when increases the kinetic energy of molecules. So when the kinetic energy increases, the heat energy also increases, and when the heat energy increases, the substance absorbs heat and thus converts from solid to liquid state. This results in an increase of the kinetic energy of the molecules, which in turn leads to increase the temperature. However, further supply of heat energy does not increase the kinetic energy of molecules. Instead, the heat energy is stored in the form of potential energy, which can be used further and gets converted to kinetic energy. So with increase in potential energy, the intermolecular forces of attraction decrease, which results in increase in intermolecular spaces. The molecular arrangement of solid changes to that of liquids. The temperature at which the solid gets converted to the liquid state at the atmospheric pressure is called melting point. Although each substance has a specific value of melting point, under normal atmospheric conditions, certain factors affect the melting point of solids. We will study that factors in another next class.